Hey everyone, it's your friendly neighborhood math teacher, Mr. Bennett. Today we're going to cover 5.1b. Our topic here, continuing in our unit on probability, is about simulations. And so we're going to look at a soda contest for our topic today. So our box here says Pepsi ran a promo contest for their 20-ounce bottles of soda. Some of the caps said, "Please try again," while others said, "You're a winner." Pepsi advertised the promotion with the slogan, "1 in 6 wins a prize." Mr. Bennett's statistics class wondered if the company's claim is actually true. To find out, all 30 students in the class go to the store, and each one buys one 20-ounce bottle of the soda. 2 of the 30 students get caps that actually say, "You're a winner." So again, right, first of all, we want to notice that their claim is 1 in 6 wins, and we found that only 2 out of 30 students were the ones who won. So to answer question one, how many winners would you expect to get out of a class of 30? So again, if we think, okay, well, 1 out of 6, what is that probability? Well, 1 out of 6 chances times 30 students is 5 students. So I would expect to have 5 winners. But is this guaranteed? No, it's not guaranteed to get exactly 5. So although I would expect to get 5, it's not guaranteed I'm going to get 5. So it's a little bit tricky. So since our simulation only got 2 out of the 30 instead of 5 out of the 30, does this result give us convincing evidence that that 1 in 6 claim is inaccurate? Like, is Pepsi trying to play with us when they know in reality it's actually a smaller percentage? So in this case, we're going to perform a simulation. So keyword there, simulation, to help us answer this question. We're going to assume Pepsi is telling the truth, right? We're going to assume that the 1 in 6 chance is true. So if they are telling the truth, what is the probability of getting 2 or fewer winners, right? Getting what we observed in our experiment here, purely by chance. So in this case, if it is actually 1 in 6, even though we're not guaranteed to get it, what is the probability of actually getting 2 or fewer? So again, we're going to have to do some analysis here and think about whether or not our responses are statistically significant. So that's what we're going to go through today to answer this question. So number 2 says, what could we use to model a 1 out of 6 probability? There are lots of things we could do. Probably one of the easiest, since we're talking about 1 out of 6, is to roll a die. So a reminder, a singular dice is called a die. So we're going to roll a single die, since there's 1, 2, 3, 4, 5, 6 on each side. So we're going to assign certain outcomes to losers and winners. So for this exercise, I'm going to say if I roll a die, and I roll a 1, that's going to be a winner. And everything else, right, 2, 3, 4, 5, and 6 is considered a loser. Okay, we could name whichever number we wanted. We could do a 3 as a winner and everything else is a loser. But for the sake of making it easier, we'll do 1. A 1 is winner. And then the next question kind of tied into that says, how would you use a random number generator or random digit table? That's what RDT stands for, random digit table. That refers to, in our last unit, right, we saw those examples of like random digits, 1, 0, 1, 7, 6, 7, 2, 4, 3, 2, 9. And we talked about taking these in an order together, depending on what we're pulling here. In this case, we're pulling 1 through 6. So anything that's not a 1 through 6 wouldn't count. So we'd have a 1, 7 doesn't count, 6, 7 doesn't count, 2, 4, 3, etc. Okay, so that's just what that's referring to. We won't use that, but we could if we needed to. A random number generator, right? We could do a random number from 1 to 6, right? Random integer from 1 to 6, and just run that however many times we need to. So part 3 says we're going to carry out this process 30 times of the students in the stats class buying the sodas, use the dice 15 times, and a random number generator 15 times. Although in this case, for the sake of ease, I'm going to do this with just a dice roller because if we were doing this in class, I might have you do both. But since we're doing this, I'm going to kind of show you this process just here in this video. So I'm basically going to need to roll 30 dice. Okay, so what I'm going to do is I have this pulled up already. I went to this website, rolladie.net. I just Googled, dice roller. And this is one of the ones that came up, one links that came up. So what I did here was I selected 15 dice here in the middle, 15 dice, and I want them to be 6-sided dice because just standard dice. And then I'm going to roll it 2 times. So I'm going to do 15 dice, but I'm going to roll it twice, and you'll see why in a second. So I'm going to hit go. And you'll see the 44 adds those up. So I get 3 rows of 5. So the reason why I did this is because I really like that it breaks it apart like this. And, that's all the way down the bottom. So here was my other first roll of 15. So as you can see here, there are no ones up here in the top. And down here, there are, I count 1, 2, 3, 4, 5. And the thing I like about this website, one of the reasons why I use this, was because I can also click show stats. And it actually tells me in that little box that I have won 5 times. So it tells me I had 5 ones. So that was my first roll. So if I go back to my notes, how many of them won a prize? We had 5. So repeat this for another 30. So I'm going to do the same thing. So I'm going to hit go again. And we got a lot of them here. And again, in this case, since I can click just show stats, I'm going to click that. And it says I've got 11 ones. So if I count up all my ones, there were 11 of those. So that means I had 11 winners. So for part 5, right, normally I'd have you guys do this in the class. It's a little bit hard because I'm not there. So rather than you guys try to figure that out with some random sub, I went through and did a bunch of trials for you guys. And so what I did was I did this dice roller thing a bunch of times, and then I actually put this into Statlet. So as you can see here, I didn't use the ones I just used because I'd just done this previously. So the highest ones I got were 10. I'm going to not pause this, but I'm going to leave this on the screen for a second. So if you want to screenshot this and put this into your notes, you're more than welcome to. You just need the dot plot. But this is what I got. So I did 30 samples of this, and these were the number of winners I got for each sample. So in this case, I had 1, 2, 3, 4, 5, 6 simulations where I had 2 winners. I had 7 simulations where I had 3 winners. I had 2 simulations where I had 4 winners, and so on. Okay, that's what this graph means here. So screenshot that, put that into your notes. So I'm going to go back here. I've actually already screenshotted it, so I'm going to slide that in. And so question 6 says, what percent of the time did Mr. Bennett's statistics class get 2 or fewer prizes just by chance, right? So those were just complete chance because we just rolled the dice. They are what they are. So in this case, again, we want 2 or fewer because remember, we could have also gotten 1 or 0, but there's nothing over here this time. So in this case, I just have to look at the ones around 2. So we had 6 out of the possible 30. is 0.20 or 20%. Now, 20% of our simulations were able to get 2 or fewer prizes simply by random chance. So question 7 says, does it seem plausible that the company is telling the truth, but that the class just got unlucky, or do we have convincing evidence that they're lying to us? So here's what we're going to say. Assuming Pepsi's claim is true, which is what we did, right? We assumed that there was a 1 in 6 chance. There is a 20% probability of getting 2 or less winners by chance. Sorry. 2 or less winners out of 30 by chance. I want to make sure we include that there's 30. So out of 30 by chance. So because of that, there is not convincing evidence against their claim. And is not statistically significant, right? And what we mean by that, we talked last time about the fact that when this probability is greater than 5%, it is not statistically significant. Because if it was low, right, we would say, oh my gosh, it was really rare to get 2 or less just by chance. Okay, so since it's happening fairly frequently, right, 20% of the time I actually get 2 or less, that means that is probably bound to happen, right? So it's very plausible that that could happen just simply by random chance. If it was low, we'd say, okay, it's not happening by random chance, it must be happening for another reason, aka they must have been lying to us. Okay, so that's again another example of where statistical significance comes into play. Okay, so that's a simulation. And we'll do some notes here on that in just a second. But again, right, just kind of a recap. We went through and said, okay, our probability was 1 out of 6. What was something we could do to model that? Simply roll a dice, roll a single die, and then do that simulation as many times as we need to. I just did 30 of them because I didn't want to spend here all night doing this. But we could have done this 100 times and got even more data. Again, similar to yesterday's lesson, right? The more simulations we can run, right? Just like the shooting the basketball, the more we can do, the closer our probability is going to get, the more accurate it's going to be. So some simulation notes. So first, there's kind of 2 main things from this lesson. So I'm going to split that about in half. So the first is simulation. So simulation is the imitation of chance behavior based on a model that accurately reflects the situation. So again, the imitation of chance behavior based on a model that accurately reflects the situation. So some examples of this. Rolling a dice, right? Whether that's a 1 out of 6, we could do a D10, we could do a D20, we could do a coin flip for a 1 out of 2. We can use an applet. We can use a random number generator, right? All kinds of different stuff to help us with this. But those are just some examples, right? There's some behavior we're noticing. We're going to use a model for that to imitate that original situation. And then for the simulation process, there's kind of some main key steps here for the simulation process. So step 1, we need to describe how you will simulate one trial. Or, in other words, one repetition. Number 2, then we need to perform many trials or repetitions. Again, right, the more we do, the better and more accurate it will be. And then step 3 is then use those results. So use the results to answer the question. Okay, so 1, describe what we're going to do to simulate it, right? I'm going to describe, okay, I'm going to use a dice. I'm going to roll a 6-sided dice. Okay, that's the description. Step 2, then I'm going to perform it. I'm going to roll a bunch of dice. I'm going to get all the data, do it a bunch of times. And then step 3, look at the results from that data, right? Either in the applet or just by looking at the counts, right? If I had just kept track of it in a table or something, and then use that information to answer the question. Okay, so that is simulation. It's using a simulation to, again, talk about probability, and specifically to estimate a probability, right? We're not actually calculating an official, this is the number. It is an estimate because we have limitations with how much we can simulate things. But sometimes estimations are enough, right? I don't have to have an exact number as long as I can give a good estimation for what we're talking about. So I will include the answers for these questions down below in the completed notes file that I'll post to Canvas. So if you have questions on that still, let me know. Again, sorry about not being able to do this with you guys, but hopefully me kind of having that prepped ahead of time made this video a little bit shorter, so you're not sitting here forever. And then you guys can still understand that and have more time to kind of work on your homework assignment for this lesson. As always, if you have questions, feel free to ask. You can message me on Remind. I will answer when I can, or I will be back tomorrow. So if you want to come in before school or during lunch or something, I can also help you out. As always, have a great rest of your day, and I'll see you guys in the next one. Have a great day.